Alright, this video I want to do a couple more examples on synthetic division. So this time I'm not going to do all the algebraic division part. I'm just going to write, do the synthetic division. So we're dividing by x minus 1. So our a term is going to be 1. And then I'm going to write all the coefficients in order. So I have 2, negative 3. I think I can do this more compactly. So I've got 1, then I have 2, negative 3, 4, negative 5, and 2. Then we're going to drop the 2 down, multiply by 1, and then sum the terms, and then multiply by 1, and sum again, and so on and so forth. Alright, so this will give us our quotient and our remainder. So since we have a remainder of 0, I know this is a factor of that term, and I could just rewrite this as 2x to the third minus x squared plus 3x minus 2. Alright, so that's great. So what if we have another one that I want to do? Sorry, what if we have a polynomial like this, x to the fifth plus x to the third plus x. And I want to divide it by, let's say, x minus 3. I'm going to draw a line here so we can see the separation of the problems here. So this is something we can do as well, but we don't have an x to the fourth term, we don't have an x squared term, or a constant term. So instead we're going to put zeros in those places. I'm not sure if I showed that yet, but so for this case we have a is 3, and then I'm going to write 1 in the x to the fifth place, and then 0, and then 1, 0, and 1. Okay, so I'm going to drop the 1 down, multiply by 3, and then sum, multiply by 3, and then sum, and then we're going to multiply by 3, so that's going to be a 30 there, sum, and then 90, and in this case my remainder is going to be 91. So what this is saying is if I want to rewrite this equation, I can rewrite it as x to the fourth plus 3 x to the third plus 10 x squared, whoops, hold on, plus 30x, wait, what, I did something wrong. I forgot the ones place here, so actually I needed another 0 here. That's not my remainder, by the way. Okay. It's kind of hard to see, but that 0, these correspond, so the 1 corresponds to the 90, so I'll write the 0 a little further over this way. So you can see that I need to multiply 91 by 3 to get 273. And then add it up, 273. That's my remainder. Okay, so the mistake I made was this was 1x to the fifth power, then I have 0x to the fourth power, 1x to the third power, 0x squared, 1x, and then I need my constant term as well. I forgot to write the constant term there. And the remainder will go under the constant term. So this is going to be the quotient here. So I can continue here, plus 30x plus 91, and kind of ran out of room here, but this is going to be plus 273 divided by x minus 3. And if I wanted to verify that these two, that this is equivalent to this, then I could multiply both sides by x minus 3 and then combine it and check that way, which I guess I'll go ahead and do. So if I multiply x minus, well, that's kind of a lot. Let's see. Yeah, it'll be fine. I'll just do it. So if I'm multiplying x minus 3 through, that's going to be x to the 5th plus 3x to the 4th plus 10x to the 3rd plus 30x squared plus 91x. Okay, so that was multiplying x through. Now I want to multiply negative 3 through by everything. So negative 3x to the 4th minus 9x to the 3rd minus 30x squared minus 30x minus 90x minus 90x, and then minus 273. Alright, so I multiplied x minus 3 through by this whole polynomial here. And then if I multiply x minus 3 by that term, so I'm adding that term onto that, I'll just have plus 273. So you can see that the minus 273 plus 273 will be 0. Okay, let's see. Plus 3x to the 4th minus 3x to the 4th plus 30x squared minus 30x squared. And then I have the difference of 91x and not, well, I'll start here at x to the 5th. X to the 5th has nothing subtracted from it, so that's good. And then I have 10x to the 3rd minus 9x to the 3rd gives me plus x to the 3rd. Okay, and then I have 91x minus 90x is plus x. Alright, so that was the step in which I verified that this statement here is equivalent to this statement. So that's synthetic division. Basically, it's a really shorthand way of doing the algebraic division. So what we did determine, though, is that x minus 3 is not a factor of x to the 5th plus x to the 3rd plus x.